Hello, everyone, and welcome. Today we're diving into something seemingly simple, something we've all played with as children, but which holds a fascinating world of science within its shimmering surface. Soap bubbles. Yes, those iridescent spheres aren't just pretty, they're a testament to physics, chemistry, and even a little bit of art. We'll explore how they form, why they float, and the amazing phenomena they demonstrate. So get ready to look at bubbles in a whole new light. Before we dive in, if you're even a little bit intrigued by this topic, be sure to hit that like button to show your support. We'll have plenty more fascinating science explorations in the future, so subscribing ensures you don't miss out. So what is a soap bubble? At its most basic, it's a thin film of soapy water enclosing air, creating a sphere. That's the short answer. But let's break that down. You can't just blow air into water and get a bubble. Water has something called surface tension, which makes it want to stick together. Think of water molecules as tiny magnets, all pulling on each other. This tension makes it difficult to stretch the water into a thin film. That's where soap comes in. Soap is a surfactant, a substance that reduces surface tension. Soap molecules have a unique structure. One end that loves water, hydrophilic, and one end that hates water, hydrophobic, and loves grease. These molecules insert themselves between the water molecules, weakening the forces that hold them together. This makes it much easier to stretch the water into a thin, flexible film. Think of it like this. Imagine a group of people holding hands very tightly. That's the water. Now imagine someone slipping oil between their hands. Suddenly, it's much easier to pull them apart. That's essentially what soap is doing to the water molecules in the bubble. Without the soap, the water would just clump together and not form a bubble at all. What other household chemicals might act as a surfactant? Let me know in the comments. Now, why a sphere? Why not a cube or a pyramid bubble? The answer lies in minimizing surface area. Nature always tries to find the lowest energy state. For a given volume of air, a sphere has the smallest possible surface area. The soap film wants to minimize its surface tension, so it naturally forms a shape that requires the least amount of energy. That shape, mathematically, is a sphere. But hold on, bubbles aren't always perfect spheres. When they're first blown, or when they're resting on a surface, gravity can distort their shape. The weight of the water in the film pulls it downwards, creating a slightly elongated or pear-shaped appearance. However, the surface tension is still trying to pull it back into a sphere, creating a constant tug-of-war. And that leads us to the fascinating world of bubble films. The wall of a bubble isn't just a single layer of soapy water. It's actually a sandwich of water molecules nestled between two layers of soap molecules. The hydrophobic tails of the soap molecules point outwards, away from the water, while the hydrophilic heads point inwards, towards the water. This creates a stable structure that can hold air inside. The thickness of this film is incredibly thin, often just a few micrometers. That's thousandths of a millimeter. And this thickness is what gives bubbles their beautiful iridescent colors. This happens because of a phenomenon called thin film interference. Light waves bounce off both the inner and outer surfaces of the film. When these reflected light waves recombine, they can interfere with each other. If the waves are in phase, meaning their crests and troughs align, they reinforce each other, creating a brighter color. If they are out of phase, they cancel each other out, resulting in a darker or even invisible color. The thickness of the film determines which wavelengths of light interfere constructively and destructively. That's why you see swirling patterns of different colors on a bubble's surface. These colors change as the film thickness varies due to gravity and evaporation. Thicker regions of the film will reflect different colors than thinner regions. This constantly shifting interplay of light and thickness is what makes bubbles so visually captivating. Isn't it amazing how much science goes into something so simple? If you agree, let me know by hitting that subscribe button. We have lots more to explore together. Now, let's talk about what makes bubbles float. It's all about buoyancy. Buoyancy is the upward force exerted on an object immersed in a fluid, in this case, air. An object will float if the buoyant force is greater than the object's weight. For a bubble, the air inside is slightly warmer and less dense than the air outside. This difference in density creates a buoyant force that lifts the bubble. However, the weight of the soapy water film also plays a role. If the film is too thick, the bubble will be too heavy to float. That's why the best bubbles are made with a thin, strong film. The balance between the buoyant force and the weight of the film determines whether a bubble will float, sink, or just hover. Ever notice how bubbles eventually pop? That's because the soapy water film is constantly evaporating. As the water evaporates, the film becomes thinner and weaker. Eventually, it becomes so thin that it can no longer support itself, and the bubble bursts. This is why bubbles tend to last longer in humid environments, where the rate of evaporation is slower. Factors like wind and dust can also contribute to a bubble's demise. Wind can stretch and distort the film, making it more likely to break. Dust particles can act as nucleation sites, providing a point where the film can easily rupture. That's why bubbles often pop when they come into contact with the surface. The type of soap you use also significantly impacts bubble longevity. Dish soap generally works best because it's formulated to create stable foams and has good surfactant properties. However, different brands of dish soap can produce vastly different results. Experimenting with different soaps and mixtures is a great way to learn more about bubble science. Some people add glycerin or corn syrup to their bubble solutions. These ingredients act as humectants, meaning they attract and retain moisture. This slows down the rate of evaporation, making the bubbles last longer. These additives also increase the elasticity of the film, making it less likely to break. Bubble wands also play a crucial role in bubble creation. The shape and size of the wand affect the size and shape of the bubbles you can create. A simple circular wand is the most common, but you can also find wands with intricate shapes that create fascinating bubble formations. The key is to use a wand that allows for a smooth and even film to form. Beyond simple spheres, bubbles can form all sorts of interesting shapes, especially when they interact with each other. When two bubbles merge, they form a shared wall that minimizes the surface area. This shared wall is always curved, with the curvature depending on the relative sizes of the bubbles. Larger bubbles will swallow smaller bubbles. You can even create bubble clusters, where many bubbles are packed together. In these clusters, the bubbles arrange themselves in a way that minimizes the overall surface area. The shapes of the bubbles in a cluster are often polyhedral, meaning they have flat faces and straight edges. This is because flat faces minimize surface area compared to curved surfaces. If you're enjoying learning all about bubbles, make sure to give the video a thumbs up and subscribe to the channel. Bubbles aren't just fun and games, they also have practical applications. For example, bubbles are used in mining to separate valuable minerals from waste rock. The minerals are coated with a substance that makes them hydrophobic, while the waste rock remains hydrophilic. Air is then bubbled through the mixture, and the hydrophobic minerals attach to the bubbles and float to the surface, where they can be collected. Foam, which is essentially a collection of bubbles, is also used in firefighting. Firefighting foam smothers flames by cutting off their oxygen supply. The foam also cools the burning material and prevents reignition. Different types of foam are used for different types of fires, depending on their chemical properties. In medicine, microbubbles are used as contrast agents in ultrasound imaging. These tiny bubbles enhance the visibility of blood vessels and organs, allowing doctors to diagnose and monitor various medical conditions. Researchers are also exploring the use of microbubbles to deliver drugs directly to tumors. Going back to the visual spectacle, professional bubble artists create incredible bubble sculptures and performances. They use specialized solutions and techniques to create giant bubbles, bubble tunnels, and even bubbles within bubbles. These performances are a mesmerizing blend of art and science. You can even freeze bubbles in cold weather. When the temperature is below freezing, the water in the bubble film will freeze, creating a delicate, icy sphere. These frozen bubbles are incredibly fragile and beautiful. They often shatter into intricate patterns when they break. The swirling colors on a bubble surface can even be used to visualize air currents. By shining a light on a bubble and observing the movement of the colors, you can see how air is flowing around it. This technique is used in fluid dynamics research to study airflow patterns. What experiment involving air currents, bubbles, and color would you like to see me try? Tell me in the comments. So, the next time you see a bubble, remember that it's more than just a pretty sphere. It's a tiny world of physics, chemistry, and art, all contained within a delicate film of soapy water. It's a reminder that even the simplest things can hold profound scientific beauty. Experimenting with bubbles is a fantastic way to learn about science in a fun and engaging way. Try different soap solutions, different wands, and different environmental conditions to see how they affect the bubbles you create. You might be surprised at what you discover. From the way light interacts with the thin film to how gravity affects the shape and how temperature causes it to freeze, there is so much to explore. From their practical applications in mining and medicine to their artistic expression in bubbles arts, these simple spheres demonstrate so much. And that brings us to the end of our bubble adventure. I hope you've enjoyed this exploration of the secret science behind soap bubbles. It's a topic that truly showcases how much wonder is hidden within the mundane. If you want to see more content like this, be sure to subscribe and enable notifications so you get our content delivered fresh to your feed. Remember, science is all around us, waiting to be discovered. All it takes is a little curiosity and a willingness to look a little deeper. So keep exploring, keep experimenting, and keep asking questions. Be curious. Think oddly.